वेलकम फ्रेंड्स, मेरे यूट्यूब चैनल में आपका स्वागत है। आज हम सेमीकंडक्टर बेस्ड सम एमसीक्यू डिस्कस करेंगे। सो लेट गेट स्टार्टेड। बिफोर स्टार्टिंग, आई रिक्वेस्ट यू टू प्लीज लाइक, शेयर एंड सब्सक्राइब माय चैनल। So our first question is, which of the following pair of semiconductor and current carriers is correctly matched? Option A is intrinsic, number of electrons is equal to number of holes. B, p-types, number of electrons greater than number of holes. Then n-type, number of electrons less than number of holes. D, bulk, neither electron nor holes. So option A is the right answer. Number of electrons must be equal to the number of holes. So move on to next question. When a semiconductor bar is heated at one end and a voltage across the bar is developed. Okay, if the heated end is positive, then the semiconductor is option A is p-type, option B is n-type, C is intrinsic, D is highly degenerate. If a heated end is positive, then it will be n-type semiconductor. Okay, so B is the right answer. Next question is, in an extrinsic semiconductor, the Hall coefficient denoted by RH is increase with increase in temperature, decrease with increase in temperature, is independent of change in temperature. D is changes with the change of magnetic field. So Hall effect coefficient is independent of change in the temperature. Okay. So move on to next question. The correct sequence of the following material is the increasing order of conductivity is. Simply, first of all, to make semiconductor into a conductor, a doping process is there. So firstly, semiconductor is there, then doping. Sorry. In the given option, here is the doped material is first given at first position. This is not the right answer. Then aluminium and the silicon is given. Then this is not the right answer. Then aluminium and intrinsic, this is not also. Then the remaining is the option D, a material and then doped with some other material, and then aluminium have less conductivity than the silver have the highest conductivity. Okay, so option D is the right answer. The mobility of the electron in a semiconductor is defined as diffusion velocity per unit electric field, diffusion velocity per unit magnetic field, drift velocity per unit magnetic field, drift velocity per unit electric field. So the right answer is drift velocity per unit electric field. Option D is the right answer. The next question is, why does the mobility of the electron in the semiconductor decrease with increasing donor density? Option A. Doping increases with the effective mass of electrons. Doping decreases with the relaxation time of electrons. Electrons are trapped by the donors. D is the more holes are generated so that the effective mobility decreases. So mainly doping is a process of adding some impurity to make it as a good conductor. So doping is decreases the relaxation time of the electron. Okay. So the next question is, what is the chemical bonding in silicon? Metallic bonding. Option B is the ionic covalent bond. Van der Waals. Semiconductor having covalent bonds. Okay. Option C is the right answer. Which one of the following is a trivalent material? Antimony, phosphorus, arsenic, boron. So trivalent material is boron. In a material, the Fermi level is located between the center of the forbidden band and the conduction band. Then what is that material? Center of forbidden band and the conduction band. Then the material is the anti-material. Option B is the right answer. Which of the following quantities cannot be measured and determined using the Hall effect? Type of semiconductor, mobility of charge carriers, diffusion constant, carrier concentration. Diffusion constants cannot be measured by Hall effect. The minimum energy of photon required for intrinsic excitation is equal to the energy of the bottom of the conduction band, the energy of the top of the valence band, forbidden gap energy, and option is the Fermi level energy. So the right answer is the forbidden gap energy. When donor atom are added to the semiconductors, option is increases the energy band gap of the semiconductor, decreases the energy band gap semiconductor, introduce a new narrow band gap near the conduction band, introduce a new discrete energy level below the conduction band. So when we add some atom into the semiconductor, it will below the conduction band. It will try to reach there, but it's slightly introduce a new discrete energy level. Option D is the right answer. Doping intrinsic silicon with arsenic as an impurity, then only increases the conductivity of the silicon by increasing the number of free electrons available, produce a semiconductor in which the charge carrier are predominantly electrons but holes are also present. Option C is produce a semiconductor in which the charge carrier are predominantly holes but free electrons are also present. Option D is produce a semiconductor in which the charge carrier contain a nearly equal number of electrons and holes. Then option B is the right answer. Hall effect is useful for measurement of semiconductor mobility, carriers, concentration and temperatures, type and type, p-type, conductivity and temperature, type and type and p-type, mobility and carrier concentration, and mobility, conductivity and temperature. So Hall effect can be useful for the measurement of n-type, p-type, mobility, carrier concentrations. Option C is the right answer. An electric field is applied to a semiconductor. Let the number of the charge carrier is n and the average drift speed is v. If the temperature increase, then n is increased but v is decreased. Option B is the right answer. Next question is, for a particular material, the Hall effect coefficient is found to be 0. The material is Hall effect is 0 for which insulator? Option D is the right answer. Next is, at very high temperature, an n-type semiconductor behaves like. At very high temperature, when we increase the temperature, the extrinsic semiconductor become intrinsic semiconductor. So option B is the right answer. Option B is the right answer. Next is, the energy gap in the energy band structure of a material is 9 electron volt at room temperature. The material is. The question is, the energy gap of the energy band structure of a material is 9 electron volt at room temperature. The material is semiconductor, metal, conductor, insulator. So this is a insulator. Option D is the right answer. In an extrinsic semiconductor, the conductivity significantly depends upon majority charge carriers generated due to the impurity doping, minority charge carrier generated due to the thermal agitation, majority charge carrier generated due to the thermal agitation, minority charge carrier generated due to the impurity doping. So conductivity depend upon majority charge carriers generated due to impurity added. Mainly impurity से ही हम अच्छा एक कंडक्टर सेमीकंडक्टर बना सकते हैं. नेक्स्ट इज, द इलेक्ट्रिकल कंडक्टिविटी ऑफ ए प्योर सेमीकंडक्टर इज. Proportional to temperature, increases exponentially with temperature, decreases exponentially with temperature, not altered with temperature. Option D is the right answer. Increase with exponentially with temperature. So that's all. Please like this video and subscribe my channel, which is most urgently required at this time. Thank you for watching.